Hello Algebra 1 students. Today we're going to be starting a new unit, or Unit 2 in my class. So this unit's going to be focused around the theme of developing patterns, and specifically we're ultimately going to be looking at two distinct types of patterns. So the first few days of the unit are just going to be focused around spotting a pattern and deciding how to make a prediction from one of these two types of patterns. So basically, ultimately, we're going to learn all we can about two specific types of patterns, and we'll build up to being able to even graph those patterns and know a lot of stuff about the graphs of just those two kinds of patterns, okay? So, the first problem that my class was asked to investigate, and if you're watching the video as one of my students or someone trying to learn algebra for the first time, you should progress accordingly. So, we're going to look at how many dots are in this pattern over here. So, how many dots are in the first figure, guys? Clearly 4 dots, right? And then we could count up the number of dots in the second figure. How many are in that one? 7? Third figure, there's a lot of dots, so carefully count them up. Is it 10 exactly? Okay, so these numbers right here are kind of like the y values in the pattern. The x values are the first step, 1, the second step, 2, and the third step, 3. Pretty simple, right? So, what's happening in this pattern? Can we kind of describe it, talk about it in words, Jack?
Adding 3 dots to each end of them.
Oh, so visually it's kind of like 3 dots are getting added to each like spoke or something, right?
One
Kind of
dot's
like,
added to each.
so here we've got an extra dot being added to each side, each spoke, I'm going to say. Here we've still got an extra dot being added to each side, so that's 3 extra dots total for this particular figure. Cool? So how does that appear in the actual answers here for the number of dots? 4 goes up by 3, which then goes up by 3, which makes sense because those 3 extra dots are what's being added each time. So now I think we've got a fair sense of what's happening. Is it an addition, a multiplication, a subtraction, or a division?
Addition.
It's an addition of dots, actually. There's some kind of multiplication. Sal's not wrong, though. So I think there's some kind of multiplication thing in here, too. But the actual pattern is going up by addition, okay? So we could just kind of see the pattern without even drawing the next figure. You could draw it, of course, and see at 4 minutes, the fourth figure, how many dots will there be? 13. I could draw it and actually add the 3, but that would take a lot of time. It'd be kind of a waste of time, right? The next one is going to be 16 because we figured out that we're adding 3 each time, right? So the problem with 25 is that we'd have to add 3 quite a few more times. So by the time you get to these, it really becomes helpful if you can develop an equation. Now you might have just like used your calculator and added a whole bunch more 3's, or you might have, like Sal said, maybe done some multiplication by 3 or something like that. Those are both possible ways to get these other answers. The way I'm going to do it is I'm going to develop an expression with x, the arbitrary number of minutes, the unknown number of minutes, okay? So in order to get that, I think it's really going to be a multiplication by 3. I think I'm going to multiply something by 3. So let's see if that works. Maybe just 3x is the answer. So let's think about what the x was going back to this again. I think I mentioned that a moment ago. What was the x for the first figure?
4.
The y is
1.
4. The x is, I'm going to use blue, is 1 because it's figure 1. The x here, the number of minutes was 2.
3.
The x here was 3. The x here was 4, and so forth, right? So 3x, let's check if that works. 3 times 1 is that 4?
No.
Not quite. 3 times 2 is
6.
6. It's not quite 7, but it's kind of close, right?
Yeah.
3 times 3 is 9, which isn't 10, but it's kind of close.
So
3 times 4 is 12, which isn't 13, but it's
Close.
kind of close. How do I fix my pattern
So
instead of
add
3x?
Plus 1.
That's it.
So it'd be 3x plus 1.
There you go.
That's what I
There's the
put.
pattern. Does that make sense, guys?
Yeah, that's pretty cool.
So you can see that even though the pattern involved addition, the equation involved multiplication, and then this guy is kind of like a fix. Now I'll tell you lots of different ways for you guys to come up with the 1 eventually, Right now, you guys just figured it out, right? You just came up with that pure pattern recognition. There's lots of ways to make it easy on yourself, but today it's all about pure pattern recognition, okay? So we've got this, so that makes these real easy. So now I can just go, well, if x is 25, then it's 3 times 25 plus 1. I think that's 75 cents, so 76,
Oh, yeah.
right? If it's 200, I can just go 3 times 200 plus 1, which is 601. And I bet a lot of you guys were able to come up with those, or maybe you're pretty close by doing it another way, but you guys see the power of this and how much easier it makes this situation? That's the goal, is for us to be able to come up with these all the time pretty easily and use them to our advantage. So I'm going to pause the video now. My class is going to work through some examples on their worksheet, and then we're going to look at a couple more. So as I said a moment ago, today's lesson is focused around investigating patterns, right? So in the first problem, we looked at a pattern that was represented with pictures. In the second couple problems, we're going to look at some patterns where the pictures might be possible to draw, but where we really just focus on the numbers and how the pattern develops. So what I want to do here first is maybe look at just this one and describe what's happening. So I want you guys to look at the actual outputs, the y values, they're called values here, and think about how they're changing over time according to the terms. So what's actually happening to those blue values? Can anybody tell me what's happening here? Dylan, I think you're up first.
Are they going down by half? Like 320?
Anybody else have a different idea, or is that what we're thinking? Jack?
Subtracting by
So subtracting by 80, minus 80, minus 80. I think minus 80 works here, but it'd have to be like minus 160 here. So it's kind of like subtracting, but it's not doing the same thing each time, so that's not the pattern. Does it? If we go with Dylan's idea of halves, 32 divided by 2 is 16, so I think that's good, and then 16 divided by 2 is 8, so I think that works for what we've got. So I think I'm going to write that one down. I think you've got it. So describe the pattern. I'm going to say the values appear to be getting cut in half. Or you could say the values are being multiplied by 1/2. Or you could say the values are being divided by 2. All of those things mean the same thing, right? So right now we're just focusing on describing it. We'll come up with equations for these later, okay? So help me predict the rest of the numbers in the table then. What does 4 produce? Yeah?
So 80 goes to 40, 40 goes to 20, 20 goes to 10.
There you go. That's it. Now, do you guys think that we could come up with an equation involving, for instance, x like we did with that other one? Yeah, I think so, but it might be a little bit harder than that other one. So I think we'll hold off on that for now. We're just focusing on the pattern. Cool? So pretty easy. Second one, I think, is a different variety of patterns. Sal, what did you see is going on? What's your idea?
They're adding positive 5.
So you're thinking it's going up by adding 5? Do we have some agreement on that? I think so. Just that plus 5 is negative 22, plus 5 is negative 17. So you might as well just fill in the rest so you can tell me
Plus
what the
5
rest is.
12,
Oh, negative 12.
or negative 12.
Negative 8. Or
Negative
7.
7.
And
Negative
negative 2.
2.
Positive 3.
Finally, it's positive after that. We can keep going, right? So I think you nailed it. So here are the values. Try to use a complete sentence, right? So here the values appear to be increasing by 5 each step. So this one, I think we could probably already come up with what the equation is. So I'm going to be talking about how to write equations in multiple forms as we progress through this unit. This guy over here was an explicit equation, an explicit relationship. In other words, it was like y equals 3x plus 1. So this one, can you guys maybe help me? It's very similar to that one over there. This one is y equals what? You have an idea, Nate?
X2, right? Just kidding. Oh, wait, no, never mind.
So we're going up by 5 each time.
So y equals
5.
So I'm thinking 5x.
Oh, 5.
So think about, I don't think it's plus 1 though, because if we go 5 times 1,
5.
we're going to get 5, not negative 27.
What about X?
5 times 2 is 10, not negative 22. 5 times 3 is 15, not negative 17. Those all seem to be very different. There's something special I can add. It's just a lot more than 1 that'll fix this.
10.
So we said, I'm going to get a different color here. The idea was, we wanted, if we did 5 times x, this would be like 5, this would be like 10, this would be like 15, etc., right? So what's the difference between 5 and negative 27?
Negative 22.
I think it's more than that.
Oh.
On a number line,
22. Positive
here's
22.
0, here's 5, here's negative 27. How far is this? I think it's negative 32.
32.
So maybe instead of adding something, I should subtract 32. Let's see if it works now.
Oh boy.
So if I say y equals, and I put 1 in, and I get 5 times 1 minus 32, and that's 5 minus 32, negative 27, boom. If I put 2 in, then that's 10 minus 32. 10 minus 32 is
22.
negative 22, boom. If I put, I can skip over and say maybe put 6 in. What am I supposed to get if I put 6 in?
3. Oh,
So 5 times 6 minus 32 is 30, minus 32 is negative 2, just like it's supposed to be. So that was kind of by thinking about what we would get and what we need to get. There's much easier ways to develop this kind of relationship explicitly as well. In this first lesson, though, you're focusing on just figuring out what the pattern is. So that was a little bit of a stretch for this first day, but I think doable. Okay? So one other note, when you're looking at your day 1 handout, there'll also be some review of function machine. Make sure you're trying to do that without a calculator if you can. And you'll also see some like multiplication of exponents. For instance, I think you'll see some things like this near the end, which you should really try to do without your calculator. That's what we're trying to develop, is our mental skills a little bit here. This will be really important for later on. So you're going to see things like 7 cubed later in the worksheet. So try to do those by hand without using a calculator. That's where the learning is going to come from. Otherwise, you're not going to learn anything. So how do I do 7 cubed if I have to do it by hand?
7 times 3.
Right? So I say, oh, I know 7 times 7. That's been
49.
something we've known for a long time.
Times 7.
So then I do 49 times 7. There's different ways to do this. Don't use your calculator. Try to develop your skills. I'll show you 2 ways. Here's 2 different ways. Way 1, 49 times 7 is just like 40 times 7 plus
9.
9 times 7. 4 times 7 is
7.
28 with a 0. 9 times 7 is 63. If I add those up, I get 28 and
336.
6. Notice how I'm ignoring other decimal places.
343.
So 28 plus 6 is 34, and then I put on the 3. There's way 1 to do that by hand. Way 2 to do this by hand. There's lots of ways. Is to say, hey, 49 was pretty close to 50, so 50 times 7 is just like 5 times 7. What's 5 times 7? 35. Add your extra 0. But then it really wasn't 50 times 7, it was
5 times 7.
49 times 7. So I take my answer and I subtract 7. What's the difference between 49 and 50? 1. 350 minus 7 times 1 is 343. So this is the kind of way that you're meant to finish the exercises at the end of the day 1 handout. Use your calculator fine, but you won't learn anything. So I hope you'll take advantage of this. See you next time.